And with this, I would jump right away into the dietary exposure calculation to food enzymes. I will detail you the approach. I will explain you how this approach came about and how we implemented this approach with its methodology. So a soft start, and that's my personal view in the title, that to me, the exposure calculation is really putting some philosophical thinking into a tangible dimension. And this is important for risk assessors. And because with whatever we learned in the university, and we all have kind of a glimpse, ideas, culinary thing, ideas, even maybe deep knowledge, good taste about, okay, dietary exposure is about my diet and the diet of my neighbor and the diet of whoever that is being a consumer. And but then when it comes to amount, we begin to enter into a little bit more tangible. And for a risk assessor, and I think this tangible dimension is probably can be very well summarized by this very famous thing that everyone knows, and from this philosopher and back in the 15th century. So in essence, it's the dose makes the poison. Yeah, everything a poison or nothing. And it's all depending on the amount. And the amount and also the effect of being a poison, they not necessarily be linear, but there is a relationship. And when I put these slides, and it occurred to me very often that I'm challenged or asked, like, well, you know, qualitative assessment works really well. And I know which cheese, which region is consuming, and what is making that cheese. And so isn't, you know, people may challenge that. I think a quantitative is just excessive and it's unnecessary. And qualitative, you have a continuous dimension. And the moment you go into quantitative, be it categorical, and that's most of the time. And the moment you put a number, you put a dot, you actually reduce the complexity, and the qualitative are far more. And I would argue really differently. And I think the risk assessment is not exactly this kind of art we visit in museum. And at the end of the day, we risk assessors we face the question is it safe or is it unsafe, in a very simple thing. So what we are trying to do with the exposure is just to put this safe or unsafe and in a more tangible way. And I will show you what is this tangible way. So here, and you know this very well, and hazard characterization of things, be it a food or be it a chemical within the food, or be it even something unintentional like contaminants, and those could be hazard. And the question I just said before, that is the food safe or not safe, is actually we are moving, and to here is about the health risk. So this is a property of a food, and here is the effect on human. So how do we go from here to here? And already the food hazard identification and the characterization is a complex word by itself, but we still need to walk the miles and here. So I think the bridge, or maybe the road to link these two, are really dietary exposure assessment and estimation. So I deliberately put out the two words, assessment and estimation. So estimation is only a part of the assessment, and is the quantitative part, and the assessment and is more the qualitative part, we could say that. And so have this, let's say, simple roadmap in your head. And today we have a lot of colleagues from EFSA. So I think I put this, you know, for EFSA, what do we do when we are asked to issue a scientific opinion? And actually, what we are truly answering is what is the average or high level of exposure in the population. And then if we really find a risk, the next question we ask is which difference of intake in a subpopulation. So we really go into, let's say, maybe dissecting the so-called risk from a general population. So this is almost a screening, a mapping exercise. And this we begin to look into details. Which population are affected? And hopefully it's not all the population. And I put on bottom of this slide is also, you know, you see that I put the European Commission. So actually, as being a risk manager, and the very first question, they really wish to receive an answer that they can translate as nothing to worry. So the thing is safe. And the moment they receive some warning signal, immediately, I think the questions are triggered within their own remit is eating less amount would avoid the risk here? Or is it eating less frequent could avoid the risk? Or what if we have a preventive action by labeling? So all these questions are risk manager, but the answer, or at least a science-based answer to all these questions is actually back to the risk assessor. And the way to manifest, or actually to answer those questions in a more pertinent way, once again, it requires dietary exposure assessment and go into more defined way. So actually, the way I see it is that the dietary exposure is bringing the food hazard into a health risk, and it's also enabling that the constant interchange and the dialogue between risk assessor and the risk managers in constant dialogue and for the benefit of protecting the consumer health. So then the next one, you say, okay, that's enough. And what about, let's go on with the calculation. Today we come here and we wanted to try things to calculate. And I would say that super short crash course on dietary exposure for those that knows a little bit, and I guess everyone knows about this equation. I mean, this equation is so simple. And it's a simple mathematics. It's only multiplication, and everyone can do. And the calculator makes it even faster. And it's about the amount consumed times the concentration that we are looking at. And so in a nutshell, we can calculate a chronic exposure and for individual persons. So now we are getting a little bit complex. So you begin to understand that the calculator is not enough anymore. So because we are calculating individual person, and if we think about the European consumer, the numbers start to multiply. And we are using each individual survey from different countries. Some country has even more survey. And it provides a distribution of a population exposure for each survey. I'm going to illustrate this, each of the bullet points, just in the next slides. Yeah, and then once this has been done, and again, we try to simplify it, and we begin to produce summary statistics using the individual data. We will have a range, and for all the populations, and for risk assessment, the very first thing what you do is you look at the mean intake, and you look at the P95 intake, because this gives you kind of conservatism, and which you need it, especially if the hazard is, let's say, the effect, the risk, the potential risk is really high at the stake. And this last bullet point, it is really a conclusion of the risk assessment. And EFSA opinion, we always draw the very first conclusion based on the P95. And okay, so this slide is actually showing you that what kind of a survey we are talking about, which country we are talking about. So this is the type of information that is available in the European in comprehensive food consumption database. So it collated the data from all the countries and stratified by the age groups. And you can see that we also included, let's say, vulnerable populations like here. And because of the emerging diet preferences, so the vegetarians, and it's also included. But if you look the numbers here, the number of a survey and number of country, and you see that this kind of consumption data is still in its infancy. And therefore, you draw the conclusion and be careful. And however, on the contrary, if you look at the adults, we have 28 surveys covering 27 countries. So you know that the conclusion, when you draw, and the conclusion is rather robust. And these numbers, so actually the number has a meaning. So the way of understanding the robustness of the conclusion, you do need to look at this kind of information behind the scene. So the calculation model, as I said, that the moment I show you these slides, you can forget about calculators. You really need statistical softwares to do this. So the way the model is doing is that you can see that here, just example of 4 individual person, and they have reported their diet over a period of time, and again, snapshots of their diet. And they report exactly what they ate in the breakfast, lunch, and the dinner. They cover the weekday as well as weekend days. And so whenever, in our case, for example, if we would have a food enzyme concentration and we would multiply, you see here, when you look at the individual row, we are still on the simple mathematics. So it's a concentration and times consumption. So people are reporting what they ate as a food. And from the food, and you are going to identify, and within that food, what portion corresponds to a food enzyme. Because eating a bagel is not eating a food enzyme, you see? And so although the equation looks very simple, and this slides already imply to you that there are some additional work needs to be done. But nevertheless, the moment you manage to do that, and you have the individual average daily intake is calculated here, and then you can see that for each country, you can have a distribution. And here is the total population. And the moment you have, for each country, you have a distribution, you have the mean here, you have the P95 here, and this is, you begin to have some data to allow you to actually simplify for, I would say, general users or general people that can understand what is really behind the number. So we would have a mean, and from this, we would have a minimum, a maximum of the mean out of all the countries, and the same is for the P95. And so these two numbers are always reported in EFSA opinions. And food enzyme opinions, food additive opinions, contaminants opinions, you will always find a table and reporting this. So this is actually how those numbers are produced. So now let's get a little bit more specific and the two enzymes. So I already tried to prepare you mentally that to do the calculation, you have the concentration, you have the consumption data, And you can see that I put the units of the concentration. I put the units of the consumption. Immediately, you will spot that you are not able to multiply directly these two numbers. It would have been really good. You can do that. And you can do so if it would be a novel food. If it's a food additive, you can, because you can recognize them in the units. Then you can multiply. Unfortunately, enzyme, you can't. And so you know that between these two factors or these two denominators, you need a bit of extra. So the question is, what do we need? And to guide you, like, what do I need? And I would like to introduce you to these slides and about the food enzyme. The peculiar thing is that you need to trace the enzyme and from the fermenter and to the foods. And this is a big challenge. I mean, you can see that if we have a raw agricultural commodity, and here the example, just imagine a crop grow in the field and it get processed somehow. So when there is a P, it means process. And this process could be chemical, could be physical, and could also be enzymatic. And so once it's harvested and it get processed into a food commodity. So we know, here I put example of green, and further processing and become a food ingredients. I put them as either flour or cereal or starch or gluten. And here you see they are under sort of treatment. And already here, enzymatic treatment can happen. Not necessarily enzyme is always added, but sometimes they are. And you can see that then let's go from the food ingredients to industrially processed food. Again, if we would apply a baking process, and then you will obtain bread, biscuits, cake, and so on and so forth. Here again, a simplified version, because if you think about yourself, what you have had breakfast or dinner, and you know that the bread can be pretty different bread, what you bought. The biscuits can be very different if you had any cake. Imagine all types of cake. And so this is just the baking story. And if we would go with extrusion technology, then we will have a pasta, we will have a breakfast cereal. So you yourself already get to the picture. Many, many, many different type. So these things are called food groups. And I would not even go into that. And what I try to tell you is that the moment the enzyme treatment happens, the earlier in the food chain or food manufacturing chain, actually the more complex to do a dietary exposure for food enzymes, because this is a ramification of everything in the middle. And you see the dietary survey is sitting here, and the dietary survey are capturing foods for cooking or for direct consumption. You see, and these are the things captured, but from here to here, even you look at the big box and you look into the ramification and you say that, well, I wish that the food enzyme assessment would be that the things directly added to bread, directly added to biscuits, or directly applied to bread, or maybe bread itself is the interest of my dietary exposure. I'm just, trying to guide you. And from here to here, the distance is far closer, so that, it's far less complex. And but for the enzyme, unfortunately, the enzyme can be applied in many different steps, and we need to deal with it. And this is why that this is a challenge, and this is also why that we focused on the food manufacturing processes in which the enzymes can be added. Because you see, I give you example of baking. So actually through baking, you obtain this. But if you trace the flour, this is only part of the cake. What if from here, the starch hydrolysis, just thinking about the sugar in your mind, a cake contains sugar. So also from here, it could end up in the same cake. This is what the consumer has been eating. So you see that there are many ways would actually and lead the enzyme residue into the food that is captured dietary survey. And for this reason that we actually painstakingly dissected the survey and dissected the foods and back to whatever we are able to do and anchoring the dietary exposure for the food enzyme from a material the enzyme is treating and to the resulting food ingredients of food directly. And this one is, again, just illustrate previously what I have said, but bring you back a little bit, you know, not to say, okay, it's too complex, I give up. No, there is no need to do that. You see, sitting on the bottom, we still have this equation of you can estimate the intake of the concentration and the consumption of foods. And then you go a little bit back, okay, for the consumption of the food, we have the European Food Consumption Database. Great, we have a very, very extensive database to work with. That is giving so much power to the whole calculation. And this one for the enzyme concentration and the applicants provide us with the data. Sometimes they provide a single value, sometimes they provide, let's say, range, sometimes they even provide with a typical use level. So all these numbers, you can make use of all of them and to set up the exposure scenario. And then in the middle, we have the ingredients. This is a food ingredients. And and in order to bridge this information with this, and we went on to tap into the knowledge of the food industry and with their recipe factors, with the technical knowledge. And by that, and we did so through all the call for data and in order to produce what I call the input data. So later you will see what are they. And when we talk about factors, so there are 3 factors. You need to understand the meaning of it. You don't need to know how to derive them because it's already done. You can critically appraise those numbers, whether they are, let's say, they are as truthful as possible, but at least you don't have to do it. So the F1 factor and is a conversion factor that is bringing that the food or ingredients consumed into the raw material to which the food enzymes are directly added. So this is the one and is bridging the enzyme use level and actually to a food raw material which the enzyme is treating. So this is the very first factor is needed. The F2 factor is the ingredient factor. And this one is so much easy for you to understand because whenever you open the food package and you will see, okay, ingredients. And I have flour, I have sugar, and I have this and that. And this is just a numerical representation of each of the descriptors you find on the food label. And for enzyme, we also derived a third factor called fraction food items. And for people are very familiar with market share, and you need to know that we didn't use market share. And this volatile information and is not publicly available. We didn't use it. And instead, we derive a factor which is independent of the market share of each enzyme manufacturer. And we simply derive the frequency of, let's say, ingredients that could have contained the residue of food enzyme and appeared on the food label, because this would give us a sense of the frequency or likelihood, if you wish, that the person consuming that food mostly, and actually what is the probability that in the muesli, the people are consuming actually contains enzyme. And so this factor is actually called proxy for reality. And so having had all these different pieces of information and given to you, so here I want to introduce you to the approach, how the food enzyme estimation came about. And if you look at it, is actually started from the intended use, and we take the use level and we talk about the food manufacturing process from which we derive the foods, and then we try to combine the use level to the different level, hierarchical level of the foods we are talking about. You see, food as consumed, food ingredient, and raw agriculture commodity. And the way we did it is mirroring this difficulty, I mean, what I showed you of how to trace the enzyme. So depending on what your tracer has to be, and here flexibility can be given. And so on this, the bullet point basically summarize, yeah, the actual consumption database-based approach, because we have the European Comprehensive Consumption Database. It's very specific to the intended use. So we are not using any arbitrary numbers. And we are not assuming everyone is eating this amount of food per day. We don't need that. We have the actual consumption data. And then here, the input, you can see we need the intended use. So what are we talking about? The use level given the dossier, the technical factors, and we found it. And then here, we have it all collated. So here, the input data actually refers to all the 4 different things. So this is approach. Okay, having had the approach, are we able to go? Not really. And having had the approach, having had all the input collated, you do a lot of homework, and then the methodology here is kind of simple, illustrated here. So again, one individual person and had milk, had a ricotta, had a cereal, and have some, let's say, yogurt. And from there, this is amount. So this is captured in a consumption database. And these are the 3 factors I talked about. And you have them readily available. And this is the enzyme dosage. And we have it in the dossier. And now you can really do the very simple mathematics. Just multiply all of them and you get this number. And so by that, we can have a total chronic exposure, and chronic just because the type of data coming here. This is a chronic exposure, okay? And you can have it in how many milligram per day. And we also know the individual body weight. So when you divide, and you would come up with this milligram of kilogram body weight per day. This is a number. So you can see that that's why it's powerful to have a consumption database enhanced. And once you have a lot of children, this one is a child, like this, then you can obtain a distribution. And then you know that we will have a mean and we will have a P95. You can derive any centile you wish. Yeah. Okay. I think that this will be really my very last slides. So I think having explained the approach and the methods, and we implement everything and come up with a web tool. And the reason we did it with a web tool, because we are very conscious that people need to make the calculation. They are not necessarily a specialist in making all the distributions or understanding the foods or understanding how to find the factors. No, we have already taken away all those burden from you. And this is a tool designed, and this would be the exercise, and you are going to just take in a few minutes with Daniele. So the floor is yours. Thank you.
Thank you, Yi, for this.